Okay, we're going to record this class. Half of it will be in French then. Okay, so since this is homecoming week, we go into homecoming mode. You know what that is? No. That means we do less work. So probably, well, tonight's homework is like super simple. We don't have to worry about tonight's one, but when we get to tomorrow one, then we'll cut it down. Like I'll just do it as examples in class, and you don't have to do it. Okay, today we start rational functions. Now, first of all, what the heck is a rational function? A rational function is a function of the form y equals p of x over q of x, where p and q are polynomials. And you guys already know what polynomials are, right?
Yes.
Okay, so an example of a rational function would be like y equal, okay, like x squared minus 4 over x squared minus 9, or something like that. See, polynomial over polynomial. Okay, now how do you graph rational functions? Well, if you just go through the 4 things I teach you, it's so easy. First, you plot the x-intercepts. Then you plot the y-intercept. Then you look for vertical asymptotes, and then horizontal asymptotes. So if you just go through these 4 things, it's pretty easy to draw the graph. Okay, how do you find x-intercepts? You set y equal to 0. So if a fraction is equal to 0, what does that mean? The top is 0, the bottom 0, both, or neither? Or none of the above? The top is 0. How can the bottom be 0? If the bottom is 0, it's undefined. So if a fraction is going to equal 0, the numerator has to be 0. So to find the x-intercept, your eyes just go to the numerator. What makes the numerator 0? Oh boy. Plus or minus 2. X squared equals 4. Come on, my dog can do that. Mon chien! That's my dog. Anyway, is that right?
Yeah.
I remember things. The last time I took French was in high school, and I can remember that. Okay, y-intercept, you substitute 0 for x. Well, if you substitute 0 for x, you get negative 4 over negative 9, 4 9. Now, when you actually draw these graphs, tonight you've got to draw 10 graphs, okay? You're not going to write these down, okay? This is baby food. This is the training wheels. You're just going to go straight to the graph and do it. I'm just doing this for you just for the first time. Vertical asymptote is when the denominator is 0 after you cancel out of factors. Because sometimes you can cancel factors, but here you can't. So you should look at the denominator. What makes the denominator 0? Plus or minus 3. So what are the vertical asymptotes? Plus or minus 3. No! Vertical asymptotes are lines. So you have to write equations of lines. X equals plus or minus 3. Horizontal asymptote. Now if you look at your notes, I gave you the rules for horizontal asymptotes. Basically, you just have to compare the degree of the top and the bottom. If the degree of the top and bottom are the same, which they are in this case, then you just look at the leading coefficients, 1 over 1. So y equals 1 is the horizontal asymptote. If the degree of the bottom is bigger, then y equals 0 will be the horizontal asymptote. And if the degree of the top is bigger, then there is no horizontal asymptote. Then you have some other kinds of asymptotes we're going to learn about tomorrow. Okay, now we are ready to graph. Okay, so plot the x-intercepts, plus or minus 2. Y-intercept, 4 9s. Vertical asymptotes, x equal negative 3, x equal 3. Horizontal asymptote, y equal 1. And there you go. So if you draw all of these things in, the graph is just staring you in the face already, right? So on the left side of this vertical asymptote, is the graph going to be up here? What do you think? It's up here or is it down here? It has to be up here. Why? Because if it were down here, wouldn't it cross the x-axis?
Yeah.
And the only places it can touch the x-axis are at the x-intercept. So now some of you, every year there's always one student goes, well, can't you just go around the x-axis? No! Well, first of all, it wouldn't be a function and the x-axis goes on forever, duh. Idiot! You can't do that. Anyway, so since the graph is exploding up on this side, what do you think on this side of the vertical asymptote? How do I know the graph is going to be exploding down on this side? Come on, you guys got to remember at least something from last year. Okay, look, if you were to factor this, isn't this x plus 2 times x minus 2? If you were to factor this, isn't that x plus 3 times x minus 3? Notice that, see, x equal negative 3 this asymptote came from this factor, right? It has an odd power on it. So if you have an odd power on it, if the thing explodes up on that side, it's going to explode down on the other side if you have odd power. If there's an even power there, then they both explode the same way. Just like in the numerator, that tells you the x-intercept, right? If the power is odd, the graph will go through the x-intercept. But if you have an even power, the thing bounces off the x-intercept. Does that sound familiar? Okay, so see, I'm going up here, I get here, I go through. How come I go through? Because negative 2 came from this factor, odd power. And not only that, you have to go through, because otherwise how are you going to get to that point from here to here? Now what? You just, okay, I got to go from this point to this point now. Now what do? Bounce off or go through? Yeah, 2 came from this factor, odd power, you go through. And then now what? You just get closer to the asymptote like that. And since the thing is exploding down on that side, what's going to happen on the other side? It's going to explode from up above because 3 came from this factor, which has an odd power. So it's going to go the opposite way on the asymptote. So it's like this. And then, wah! And do you guys know why when the graph approaches negative infinity or infinity? In other words, when the graph goes out to the left and the right, the graph will get closer and closer to the horizontal asymptote. Did you guys learn why last year? Okay, I'll teach you one, just this one, okay, just to show you. What does this bar mean, right here? It means divided by. So what happens when you actually divide that by that? Well, let's do long division. X squared minus 4 divided by x squared minus 9. X squared goes into x squared how many times? 1. Then you multiply that times the divisor, x squared minus 9, subtract. 5. So when you divide this by this, what you actually get is you get 1, the quotient, plus the remainder over the divisor. That's just writing it in a different form. Now what happens when you plug in either a super huge positive number for x or a super huge negative number for x? What's going to happen to this? Like if I plug in a million or negative million, what's going to happen? It's going to get really close to 0, right? 5 over a million squared minus 9. So that's why when the graph is going out to the right or the left, this thing here approaches 0, and that's why it gets closer and closer to 1, which is the horizontal asymptote. So it's easy. Just remember the pterodactyl. As the graph is going out to the left and the right, see like that. It's getting closer and closer to the horizontal asymptote. Okay, let's just look at some more examples. Okay, it took me a long time to explain that, but when you actually do it tonight, one graph should take no longer than a minute. Minute at the most. Okay, let's do something like this. X minus 1 over x squared plus 1. I bet you have a problem that looks almost like that. On tonight's homework. Yeah, look at B. Except it's x minus 2. I better not see it on the board tomorrow. Okay, go through the 4 things. X-intercept. Quick. Look at the numerator. What makes the numerator 0? 1. Y-intercept. Plug in 0 for x. Look, negative 1. Vertical asymptote. What makes the denominator 0? Plus or minus 1? No, nothing. No real number, right? Imaginary numbers, but we don't graph the imaginary numbers on the Cartesian planes. So no vertical asymptote. Horizontal asymptote. If the degree of the bottom is bigger than the top, y equals 0. Okay. Okay, here we go. So what do you think? Well, you know the graph got to pass through this point and this point. So it's got to go like this. Now go through or bounce off. This x-intercept of 1 came from this factor. There's an odd power there, people. It goes through. Now what? I don't know what to do now, Mr. Park. Ah! If you have a horizontal asymptote, as the graph approaches infinity or negative infinity, it's got to get closer to the horizontal asymptote. Okay, now what about over here? I don't know what to do. Ah! And there you go. That's what the graph looks like. Now, are some of you troubled by, look, Mr. Park, the graph is crossing the horizontal asymptote. I thought you couldn't do that. Well, obviously you can. There it is. Yes, so lots of times the graph will cross the horizontal asymptote. It just gets closer and closer to it out here as x approaches infinity or negative infinity. That's when it starts getting closer to the horizontal asymptote without touching it. But lots of times inside here, the graph will cross the horizontal asymptote. Do not be surprised by that. Okay, let's look at a problem where we got even powers and stuff like that. Let's just skip right to the hard one already. X plus 1, x minus 2, all over x minus 1, x plus 2. And which one, where do you want to put a 2 on? A, B, C, or D? D. And then let's put a 2 over here. Which one? Left or right?
Right.
Whatever. Just do it. See, if you understand what I'm going to do here, then it's all easy. Okay, x-intercepts. What makes the numerator 0? You got to be joking, people. It's in factored form. -1 and 2. That was French. Y-intercept. Plug in 0 for x. Okay, this might take a while. Plug in 0. If you can't plug in 0 for x, you know what the sad state of affairs that is. So 1 squared is 1 times -2, all over -1 times 2 squared, which is 4. So the y-intercept is 1/2. Because if you get the y-intercept wrong, your graph is all thrown off already. Vertical asymptotes, when the denominator is 0. What makes the denominator 0? 1, so x equal 1. And normally you should always label your asymptotes, yeah? And x equal -2. And then what about the horizontal asymptote? Okay, if I were to multiply out the top, wouldn't the first term be x cubed? If I multiply out the bottom, wouldn't the first term be x cubed? So if the degree of the top and the bottom are the same, how do you find the horizontal asymptote? You look at the leading coefficients, 1 over 1. So y equal 1 is the horizontal asymptote. Okay, so on the left side of this vertical asymptote, is the graph going to be up here or is it down there? It's got to be up here. Why? Because otherwise it would cross the x-axis, but it can't. It only can touch the x-axis there and there. Okay, now since the thing is exploding up here, on the opposite side, what? Is it exploding up there or coming from below? Look, -2 came from this factor. It has an even power. So that means they both got to shoot up the same way like that, so it's up here. Okay, now, I'm crossing the horizontal asymptote. Is that troubling? No, because horizontal asymptotes only take effect out here. Ah! Okay, now what? Go through or bounce off? Look, -1 came from this factor. It has an even power. You bounce off. Okay, now what? Go through this point and then what? Do I go up or do I go down? Who said down? You gotta go up, because if you went down, you would cross the x-axis, and there's no x-intercept there. You can only touch the x-axis if there's an x-intercept there. Okay, so the thing is exploding up on this side, so on the opposite side, is it gonna explode up or explode down? Look, x equal 1 came from this factor. It has an odd power. So that means they're gonna go opposite ways, so that means it's down here. And then, woohoo! Now, do I go through this point or bounce off? Look, this x-intercept of 2, what factor did it come from? It came from this factor, odd power, it's going to go through. So it goes through, and then I don't know what to do. Ah! And that's what the graph looks like. That's how you handle odd and even powers. So the odd and even powers in the numerator tell you whether to go through or bounce off the x-intercepts. The odd or even powers in the denominator tell you whether they're going opposite way or the same way. You guys learned this, right? Or you guys just plot points last year? Okay, don't answer me. Never mind. I don't like to be answered. Okay, next example. Y equals x squared minus 4 over x squared minus x minus 6. You probably have a problem like this on today's homework. Okay, now what you might want to do, it's up to you. Some of you can do this in your head. You might want to put it in factored form. A, it's the part. I can cancel x plus 2. What happens when you cancel factors? What's going to happen? Okay, Mr. Rubash's students? Red flag! Mr. Takayesu? Hole! So if you can cancel factors, you just cancel them out, and then this is what's left. So you just graph what's left over. Don't try to, because if you put a vertical asymptote where x is negative 2, that's wrong already. That's a fatal error. If you can cancel factors, cancel factors. Okay, so now we're just going to graph this right here. So go through the 4 steps again. X-intercept. 2. Y-intercept. 2/3. Vertical asymptote. X equal 3. Horizontal asymptote. Y equal 1. Okay, so can you see the graph is gotta be right here? And then on this side it's gotta be. Okay, box set, that's the answer. No! We canceled out factors. So whenever you cancel out factors, there's going to be a removable discontinuity. That's the official name now. It's called a removable. I'm not going to call it red flag. That's ridiculous, right? Removable discontinuity. It's not a hole. It's not a red flag. What an open circle. No, no, no. It's called a removable discontinuity when x is negative 2. So when x is negative 2, there's a removable discontinuity there. Because if you try to plug in negative 2 into the original function, it's going to come out some 0 over 0. Undefined. What are the now, whenever you have a removable discontinuity, you should always give the coordinates of it too. So the coordinates of this point are negative 2, comma what? How do I figure out? Mr. Park, I can't plug it in because it's come up 0 over 0. It's undefined. That's right. You plug it into this one. Because that's the point on the graph, right? So if I plug in negative 2 for x here, what do you get? Negative 4 over negative 5, which is 4 bits. That's the coordinates of the removable discontinuity. See, so I pretty much covered everything. So tonight's homework, either the degree of the top and the bottom are going to be the same, or the degree of the bottom is going to be bigger. Tomorrow we're going to learn what happens when the degree of the top is bigger. Then you get slant asymptotes. Did you guys do that last year? Or parabolic asymptotes. Or cubic asymptotes. So we'll talk about that tomorrow. Here, since this is homecoming here, this is what I want from your homework. Okay, just pick one problem for your homework. Just pick one. No! You guys are so dumb. No, that's too easy. Pick the hardest one and the easiest one. How about pick a medium one? In fact, didn't I just do D for you on the board? Oh my gosh. This is dumb. Okay, somebody pick something then. I. No! In fact, all of these problems are too easy, I think. C. Never mind, I'm just going to make up my homework already. Okay, this is what I want when you do your homework today, okay? Why don't I give it to you in factored format? X plus 2, x minus 1, all over x minus 2, x plus 1 squared. Okay, this is what I want. Okay, can I cancel anything? No, so no removable discontinuities. You just fly through it. X-intercept, negative 2, 1. Y-intercept. If we cannot plug in 0 for x, what pair do we have? Okay, do this then. 2 times negative, too many. All over negative 2 times 1. What is that? 1. Make sure you get the y-intercept correct now, because it'll throw off the whole graph. Vertical asymptote. X equal 2. X equal negative 1. Okay? Horizontal asymptote. If the degree of the bottom is bigger than the top, which it is, then it's what? No, it's y equals 0.
Y equals 0.
Do I have to write y equals 0? No, we already had the x-axis labeled. Y equals 0 is the x-axis. Okay, now over here, we don't really know. So we don't really know if the graph is going to go like like that, or like that. So look for other clues, like here. I know the graph gotta pass through this point. So the graph over here gotta go upward, because if it went downward, then we cross the x-axis, but there's no x-intercept there. Now, coming over here, do I go through this x-intercept or bounce off? 1, this is 1. What factor did 1 come from? This one, odd power, so what? It goes through, so it's gonna go down here. Now we can figure out everything. Look, if the graph is exploding down on this side, look, 2 came from this factor, odd power. So that means on the opposite side it's going to be up there, and then -1 came from this factor. Ooh, that's an even power. So they got to both explode up the same way. Okay, now I'm coming down to this x-intercept. Go through or bounce off? -2 came from this factor, and that's an odd power. You go through. You guys are just 50-50 chance, and then I don't know what to do. As the graph goes out to the left and the right, the graph got to get closer to the horizontal asymptote. Mr. Park, the graph is crossing the horizontal asymptote at 2 points. It's making me uncomfortable. It shouldn't, because I'm telling you, it crosses the horizontal. In fact, later on, I'm going to ask you, at what points does it cross the horizontal asymptote? Well, duh, right here it's easy, right? But later on, on the tougher problems, you can't really tell like that. Okay, so tonight's homework. So like if you get the easy ones like that, okay, I'll just do one since it's homecoming. Pick one. No. Pick like something from the middle.
G.
Okay, G then. 1 minus x squared over 1 plus x squared. Okay. X-intercept, random jump, don't take the y-intercept. Vertical asymptote no more. Horizontal y equal -1. Woo! And then that's what I want. What else can the graph do? Right? You got the x-intercept and it goes through and then right? But you guys have to practice so you can get good. Okay, let me pass back the test. I put all the solutions on the board. So a lot of you already know what you got because you guys came in. Yeah. So the black number in the upper right hand corner, that is your quarter average. Right? So that's with the extra plus 1%. And believe me, some of you need it. Wait, we gotta turn off the video. What? Maroka? Saito? Chen? Tan? Yep. Y'all. Hey, where's your yours? Okay, you can look at that. I gotta turn off the video. And then I have